So welcome to another Thursday Thought. One of the things that I wanted to address was this talk around IT versus OT, and there's a lot of hype around it and what we should do and what we shouldn't do, and people have a lot of opinions. I'd like to tell you why I think the discussion about IT and OT is actually a redundant one, and I think the whole concept of managing your shop floor needs to be rethought from the ground up. In fact, what I think is we need to all take a digital first approach to the shop floor. An example of a digital first approach is Airbnb taking a digital first approach to their hotel business versus Hilton, which is taking a hardware approach first and then adding digital on top. And that's the approach I think we need to adopt on the shop floor if we really want to take advantage of the opportunities in Industry 4.0. And the way I think we need to go about that is really rethinking what is that infrastructure for a digital first shop floor. And to help me explain that, I just want to use the concept of an operating system. So let's dive in and talk a little bit about what an operating system actually is from a high level. And I know the IT guys are going to go at me on this, but this is just from a conceptual perspective and how I think it needs to be applied onto the shop floor. So, an operating system. So one of the many functions of an operating system is obviously managing the hardware. So things like hard drives, CPUs, RAM, etc. And the fortunate thing over time is that the communication protocols to things like CPUs and hardware, like hard drives and RAM, has actually become more and more standardized over time, which makes the accessibility of different hard drives and CPUs much easier to plug in and plug out. So it's pretty easy nowadays to add RAM, pretty easy nowadays to actually add hard drives without any software changes required on your operating system. Then we have a number of obvious input devices, things like keyboards and mouse that are obviously interacting and being managed by your operating system so that other applications can use the keyboard and mouse. We obviously have output devices. The most common one is obviously a screen using the standard communication protocol of HDMI. I know we're switching over to USB-C now, but majority of screens nowadays communicate via HDMI. We also have, let's call it secondary output devices, things like printers, maybe speakers. And fortunately, over the years, this communication protocol has pretty much standardized to USB and now evolving to USB-C. And I think this has really made it access to operating systems extremely accessible from different hardware types. So nowadays, you just plug in a USB mouse, you plug in a USB mic, speaker, and the standard has been set, and so operating systems know how to communicate with it. The app on your laptop understands how to communicate it. So the fact that these communication protocols have become standardized is fundamental to the scalability of these operating systems. And then obviously on top of that, we have the different apps, functions. We obviously know all of the different apps that run on your laptop, and obviously there's user management that is taken care of by the operating system, and many, many other functions. But from a conceptual perspective, this is exactly what an operating system is. Examples are Windows, Apple, Android, etc. So how do we take this concept and apply that to a potential shop floor operating system? So this is how I think it needs to look. And we've attempted to do this, and we actually have a number of production lines running using this concept. We call it Odin Workstation, and there are a number of, let's call it features and functions built into the system. The first one is manual operations. So we have a standard communication protocol to a manual interface, so we can manage the operator's tasks in a step-by-step manner, very much like Google Maps routes the operator through a particular process. We're able to do that and dynamically change the operations based on the product that is being built in that particular station. We also manage let's say the operations within automatic stations. So you have typical automatic stations that would do 5, 6, maybe 20 functions. And the operating system that we've developed is able to tell that automatic machine what to do, when to do it, record the data, quality data, process data, machine data, all being managed by this operating system. We then have probably the most complex scenario is where we have semi-automated machines where we have to manage the coordination of operators and machines. And ultimately what the operating system is doing is using the bill of materials, bill of process, and creating operations from that and being the master orchestrator of the human and the machine. So it's really this human-machine collaboration orchestra, the orchestration of the human-machine collaboration. Then obviously there's a number of built-in functions, like we have the obvious things like user management and that kind of standard functions that are built into our operating system. But there's key specific functions that are required on the shop floor. So things like inputting your bill of materials, linking the bill of materials to the bill of process is so fundamental. So knowing that if I pick a particular part, I need to press a certain force. If I pick another part, I need to bolt with a different torque. So the linking of bill of materials and bill of process is so fundamental. Obviously, all of this is within a data structure or a data management element within our operating system. We also have built-in functions that we call, for example, path management. So if a product needs to go from station 10 to 20, but if there's a failure in 20 and it needs to skip 30 and 40 and go straight to 50 or a rework area, that concept of path management is built into the operating system. The operating system actually doesn't care whether it's manually being pushed on a conveyor system, on an AGV, or levitating on a lever board. It doesn't really matter. The path management and the coordination of where a part needs to go based on specific outcomes of operations is fundamental to the function of that production line is all managed by the operating system. Obviously, traceability is key. Genealogy, so as the product goes through the process, we're tracking every single operation, every single result of the operation, every single time stamp. We have this granular data that can be used for further analysis, and we create the genealogy of the product. So we know exactly where it was, how long it was there, what is the outcome of each operation, good, bad, pass, fail, forces, displacements, pressures, temperatures, it doesn't really matter. That whole collection of data linked to that unique part is managed within that operating system. And then obviously one of the key things is building apps on top of the operating system. So as you do with Windows, you can put different apps on there, Word, Excel, whatever these apps are, you can add them onto the operating system. And that's exactly what we've been able to do. So we're able to add analytics apps onto it. We're able to make interfaces to things like ERPs and MESs. And I think one of the most fundamental parts of why considering or switching from the typical ISA hierarchy to an operating system concept is so important is because if we really want to take advantage of prescriptive AI and machine learning, we're going to have to rethink how the data and processes are managed on the shop floor. So there's no point in being able to record a lot of data, get particular outcomes from that data from an AI algorithm, for example, that says, okay, what we need to do is we need to increase the press force of a particular process. If you're not able to actually effect that change of increasing the press force back down onto the shop floor, then your AI is a waste of time. And right now, with the separation of systems from PLC, SCADA, MES, ERP, to basically feed information back down onto the shop floor at a granular level, like for example changing press force, is extremely difficult and nowadays pretty much impossible because of these layers. And so that's why I think viewing the future of Industry 4.0 and taking advantage of those technologies has to be viewed with an operating system in mind. I'd love to hear your thoughts. Here's another Thursday Thought.